Hey guys, welcome back. So 4.3 talked about showing that triangles were congruent or the same by showing all three sides and all three angles were the same. That will work every time, but sometimes we don't have enough information to do that. So there's a couple of shortcuts that are enough information to show. So even if you don't have all three sides and all three angles, there's a couple things you can do to still show that the triangles are congruent. So we're gonna look at two of those today. One of them is just to show that all three sides match. Here's kind of a visual of it. The red pieces match, the blue pieces match, and the purple pieces match. And because the sides are all exactly the same, it has to be the same size. The angles then therefore are also the same because they're connected by same size pieces. So it is enough to show that all three sides are the same because then the angles have to be the same as well. So side, side, side is one choice. It shows that all three sides match, and that's enough to tell us. The other one is called side, angle, side, and this order is really important. The angle has to be in the middle. That way it shows that the sides are open the same amount, like a door that's cracked open the same amount. So the angle has to be in the middle of the two sides. So here's an example. It has the red sides that match and the purple sides that match, and then the angle is in between. You can't show just any angle because you're trying to see think of it like a door. It's open the same amount. So if this is the door and then this is the wall, it is open the same amount in each picture. And then over here, the same amount. So it needs to be the angle in between. So the two sides and the angle in between matches. So here they show the reds match, the purples match, and the angle, the blue one in between matches. So those are our two shortcuts, side, angle, side, and side, side, side. So let's do a little proof. So this one to me doesn't look like enough information to show all three sides and all three angles. I actually know nothing about the angles, so one of my shortcuts is probably going to help. So we have our statement and we have our reason. And I know this takes a little bit, but I think the color coordination kind of helps. So if I have purple, this one, and let's go green. It's a little bit laggy because it's recording. So the first thing said that SU and RT are the same. So I will write it out in one color to start. RS is the same as UT, and RT is the same as SU. And those are both given. So to add a little color to this, RT right here and SU match up. So I will highlight those. SU is green and RT is purple. And then it also tells us RS, which is purple, matches up with UT, which is green. So it is saying this line matches with this line. It's going, it's thinking about it. So I have two sides. My guess is the easiest shortcut to do would be side, side, side. And it looks pretty obvious here. This one, the TS in purple, is the same as the TS in green. And the reason we can do that is because it's the same line. It's literally TS in both cases. So we can say with the reflexive property, those are the same. So be careful, the triangles are a little bit spun around. So if we're looking at which ones are actually the same, we gotta watch the order of our letters. So I'll plug these in here. This one's T, R, and S, and then the green one is S, U, and T. So if I spin those, we've got, let's spin this a little bit. Well, you guys can tell it's a T. So I have SUT matches TRU. Or the order they went in is RST matches UTS. So as long as you could say TRS is SUT, as long as you follow, like if you start here, you have to go in the right order. So let's just stick with the order they gave us, which is triangle RST is the same as triangle UTS. And the reason here is because all three sides match. So we don't need to show all three angles because that was one of our shortcuts. Side, side, side. And that is the end of that proof. So these aren't as bad. I don't think they're that involved. You just have to show the three sides match. Another example is, oh, they didn't make us do a whole proof. So this one just wants to know, like, what would you need to know to use side angle side? And what they're trying to get at here is if this is your purple one, and this is your green one. The lagging is making me nuts. You already have an angle that matches. It's this one right here. They're both right angles. And then with reflexive property, you know that AC for the green matches AC for the purple because it's literally the same line. So if this is going to be, if the right angle is going to be the angle in the middle, the piece of info you would need to know that they didn't put would have to be that these match up. So if they had told you something like this, that these are matching, you could say side angle side to prove this triangle. They didn't tell us that, but they're just asking, like, what would you need to know? You would need to know, that BC, the purple one, would have to be the same as CD, the green one, and they would have to either put it in the givens or draw something on the picture just to let you know that those are equal or congruent. So that's a little intro to side angle side. This is just asking, like, what would you do if you're trying to prove them congruent? This one needs that. Honestly, that was just a typo. It came off. But if it had these two marks, you could say that this one matches this one. You could say, let's change our colors here. You could say this one matches this one, and then you've got an angle in between that matches. So let's make one green and one bluish. So you have two sides that match. Again, sorry, this was a typo. That should have these marks on it. Two sides that match, and then the angle is in between. So you could say side, angle, side. This one right here only has it has one side and one angle that match, and that's not enough. So this is not enough information to even be able to prove it. This one, however, has all three sides that have a match. So there's a match, there's a match, and there's a match. And so you could say side, side, side here. And then I threw this last one up here because it does have a side that matches, a side that matches, and then an angle that matches. but the angle is not in between. So like we said, it has to be in between so that it's like a door opening to where we have this part of the triangle and this, and we know that the door opening is the same. So since this angle is in the wrong spot, we can't actually tell. There's not enough information. So a lot of people want to put side angle side, but the angle is not in between the two sides. So that's a little review on 4.4, which is side, 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 and side, angle, side.